Hello, everyone. I am Ali. I am stoked to be able to present a talk here for you at ETHGlobal Sydney, the first one in Australia. I'm obviously Australian with this accent. Really should have said g'day all, not hello all. But anyway, good to meet you here on home turf, and really looking forward to being able to sponsor this round. So we're putting together this video to hopefully help you understand what Lilypad is and how you can use it in your hackathon applications on the weekend. Speaking of, I wanted to introduce also developer Steve, who is our CIO, and he's joining us at Lilypad as our CIO, obviously. He has a long history in developer relations as well, and in data acquisition. Steve, I'll let you introduce yourself or say hello as well, though.
Hello, everyone. Well, hello from the past because we're recording this in the past, as you all know. But hello, my name is Developer Steve. I am CIO at Lilypad, as Ali just said, and have been around. Well, I've been coding since the days of the Atari 800 XL on QBasic, which obviously we've come a long way since then. So, but always looking forward to geeking out with everyone and talking about how we can help you run your compute jobs.
Absolutely. And I'm super excited to be here specifically because this is a project that I've been working on for the past like 6 months or so now. And you can use it for all your AI, ML, and other compute jobs today. And it's kind of a project that is really a passion project for me because it's got some real whys to it, which I'll get into in a second. Let's get into the agenda first. So in this kind of workshop, we're going to explore the architecture of Lilypad, how to run a node, how to build a job module, and we'll also delve into the technicals behind Lilypad, providing you with kind of a comprehensive understanding of how you can use this platform, how it operates, and how it can perhaps be harnessed for various Web3 and also general compute applications as well. So whether you're an experienced developer or new to the world of decentralized computing, we're really hoping to provide you with the insights and skills you need to leverage the power of Lilypad for your own apps and dApps this weekend. So let's dive into it. So this is some background on Lilypad, and it's a story about data and infrastructure. If we think about what the modern web stack looks like, it's all about data. We either want to move data around, store data, or make data useful. And these three components, kind of networking, storage, and compute, form the basis of pretty much everything we do in today's connected era. So, however, compute's kind of been so far a missing piece of the decentralized infrastructure story, if you have a look around, with a few experimental exceptions, of course, and more popping up this year, which is absolutely awesome. So, this is likely for a couple of reasons. Firstly, the complexities involved in building a fully distributed compute network are pretty large, and the research is ongoing. And there's also like a whole variation from white to black, really, like a whole gray area of different types of compute that can be done. So when you're talking about decentralized compute, it's really important to kind of quantify what exactly the compute is that you want to be doing on it, and what you're really optimizing for. So secondly, I think the reason that it hasn't happened up until probably this year is we just weren't quite ready yet. There were kind of more pressing problems to solve, like internet scale storage coming from Filecoin from me, or block scaling solutions, all the L2s that we've seen crop up, some of the ZK networks that are cropping up. All of these are really important pieces of the puzzle. And even account abstraction as well has been a really important part of growing as an ecosystem. So I think, though, that compute is really it's never been a more relevant problem than it is now. I mean, you can't turn around without hearing about AI these days, especially if you're in tech. And there's a massive reason for that. I mean, I think AI is really one of these technologies that is going to fundamentally change how we operate in the world. And it's driving this exponential demand for compute and compute resources at the moment as well. And it's not just demand for training large foundational models like ChatGPT or Llama, or that Facebook recently open sourced, and bravo to them for that. It's also currently really only the domain of large companies. These training of the large foundational models is really only the domain of large companies with access to these vast amounts of data and compute power at the moment. this is a centralization point I'll circle back on though. But the demand for AI compute also includes running AI jobs, inference models like Stable Diffusion text to image or LLM prompts, or fine-tuning models via LoRa or other emerging algorithms. So this is what is really deriving the demand for compute. So not just the foundational models, but also the usage, this mainstream usage of AI at the moment. And both of these are really a space and future we're hoping that the Lilypad network can play a big part in helping create. And it's a space that I've personally dubbed the now frontier of open infrastructure. Because coordinating like these global actors in a network and creating efficient distributed peer-to-peer marketplaces is something that the Web3 space is really uniquely positioned to provide and incentivize at scale. So Lilypad is a flexible, global, and permissionless distributed compute network at its core. It enables these internet-scale computing jobs, including AI and ML workloads, while also unlocking idle processing power and new marketplace opportunities for participants. I'm going to dig into like being a bit more open about what that means shortly as well. But in practice, it means we're building a marketplace for compute jobs, or kind of a coordination layer for compute jobs, aiming to be able to provide more accessible and cost-effective computing power to consumers with this like independent global marketplace that uses this distributed hardware network with inbuilt trust mechanisms. And that's super important. Because if we don't have these trust mechanisms, I mean, as crypto natives, you are probably all more than aware of this, but if we don't have these trust mechanisms, then it makes it very hard for a network like this to run, which is why most things are centralized. So as an example, if you want to run a text to image model, then you could do that on our network of hardware. Alternatively, if you have a spare compute around, you can put it to use and be rewarded for it by running verified workloads for other people. That doesn't mean ZK workloads, but we'll get back to the consensus mechanism in a minute. And we want to make sure that it's easy for people to use as well, because you shouldn't need a degree in AI to access this state-of-the-art open source models for your next app idea. It should be as easy as any web UI out there makes it. And you shouldn't also need a fortune to keep a cloud GPU running so that you don't lose access to it for the training job you need to run once a week. So both of these are kind of the flip side of the coin to accessibility that we are hoping to provide. I think just as a bit of an off my notes example as well, I was listening to this really great podcast on Y Combinator the other day that was talking about all their AI companies that they'd funded or that had gone through Y Combinator this year. And they said fully half of them, so Y Combinator actually provides access to a batch GPU resource, which is, amazing. So that's probably worth more than the 500,000 that they get for being part of Y Combinator. But they get access to this batch computing immediately on day one with no waits if they're doing an AI thing and they want to train a model on it. And Y Combinator was saying on this podcast that fully half of these people had never done AI or ML. They didn't have AI or ML background, but they'd spent 3 months or so reading the papers and they were up to date. So that's where we're at in terms of AI development. And I think, a lot of people could spend that time to start creating some really unique models. And I think we're just going to see more and more of an explosion of those. And it'd be great to be able to offer that kind of compute power to a wider community than, obviously just the Y Combinator alumni or startups. Off the books there, but just as an example. Anyway, so what are some of the reasons why we need distributed compute? That accessibility piece is obviously one that I like a lot. And if we look at the kind of current compute landscapes, we have this scenario where there's only a few dominant players in the compute and infrastructure market. And this really makes for an effective oligopoly on storage, on compute, on infrastructure, and this can lead to some really negative outcomes for our current society, kind of the least of which is it stifles innovation. So it's also these same players, if you have a look at it, who have this access to a vast amount of data and powerful compute hardware that are able to currently dominate the AI space. And they're even now pushing for regulations that essentially mean that all AI models should be closed source and proprietary. I mean, what? This kind of rampant anti-competitiveness under the guise, to me, of safety, as arbitrated by the corporations, of course, is really absolutely wild thinking. But I'm sure a few people out here have definitely been blown away by the capabilities shown by things like OpenAI, as I have. I'm a big ChatGPT user. I'm not going to say no to a tool that helps me do my daily jobs. I'm wary, though, that what's happening here is effectively vertically integrated AI control. So this is where models and our access to them are either a black box, are rate limited, or they have other questions on their origin. What we really need is fair and actually open AI and access to technology this technology that's poised to really massively change our society, at least as much as the internet did. So it's in both these spaces that we hope that Lilypad can help provide value and help to co-create a vision for both distributed, crowdsourced open compute and a vision for building a decentralized, actually open AI stack. Sorry, Sam. Anyway, so as I was mentioning before, compute accessibility is one of the major innovation blockers currently, but we don't specifically have a compute shortage either. If you look around, everyone's got a really powerful device probably sitting on their desktop at the moment. If you're looking at the future of Macs, for example, they're implementing a new chip that will be able to run things like AI inference models on them. So, I mean, if you're able to harness some of that inefficient resource allocation, then all of a sudden you can look around the world and go, well, actually, like there is a lot of compute out there. We can make it more efficient. This is better for the environment. It's better for markets. It's better for anyone that wants access to compute. So this is one of the things that we're trying to do here. Match this exponential demand for AI jobs with idle supply, not just personal ones. Obviously, there's a lot in data centers that could perhaps contribute to other networks for a few hours a day and earn more economic resources to do so. So also useful for them. So it's not just philosophical, but also practical for these networks. So Lilypad is one of the major whys for Lilypad is this capability for decentralized AI with a distributed compute network like Lilypad. So in the same way that this one company shouldn't control access to scientific breakthroughs, central entities should not control access to AI advancements or the data sets they're trained on. So we should all really be stakeholders and owners in this future, and we should all have the capability to have a say in its collective future direction. This is actually something that Peter Wang, who's one of our advisors, really eloquently explains in this evolving property and rights video for an AI era. Like he does a great job of walking through and just like making you see just how useful a community is for things like arbitrating here. So what's also interesting when talking about open source AI, though, is that according to this leaked Google article, and this is like about a year old, maybe a little bit, it's about a year old now, 4th of May. May the 4th be with you. How about that? According to this article, though, it's also clear that open source AI and ML is outcompeting some of the centralized versions because they're able to define use cases and fine tune more easily. Now, I'm not saying that there's a model out there made in open source that is out competing, say, ChatGPT, but I am saying that we can outcompete ChatGPT on many other variants because we're able to see the use cases, we're able to fine tune to specific data, and we're able to fine tune on less data points. So you're also able to target where the common good kind of lies better. So much like Arduino's revolutionized hardware at one point and IoT development by giving hobbyists access, giving people and developers the tools for AI and access to compute power, this speeds up the solutionizing and innovation space, in my opinion, anyway. This was one of our original theses. This brings up the problem that Elon Musk eloquently described last year as well, access to GPUs. And it's a problem that everyone has experienced, even OpenAI at the time. There's been some mitigation of that, but the demand has certainly not gone down, and the price has certainly not gone down either. So this access to GPUs at a reasonable price is another key issue for open source AI and ML. to be competitive in the market. GPUs are everywhere, like I said, so we just need to allocate them to the market efficiently. And this is where decentralized physical infrastructure networks, or DPINs, really shine. That's in their ability to create efficient marketplaces with open participation and fair incentive structures. So this is not unlike the way that Uber disrupted the taxi industry with a peer-to-peer model in the past either. So Lilypad also offers efficiency of pricing and distribution. This one is probably practically obvious for a lot of folks, but generally, Lilypad brings better pricing and global hardware distribution by enabling like kind of a coordination layer to match the demand for CPU and GPU with supply. And this kind of brings more efficient market dynamics and like helps distribute to more parts of the world as well. If you have a look at the centralized data centers, obviously they're in specific areas in the world, and there's a lot more that we can service without needing to rely on a centralized data center. So just to recap, in both practical and kind of philosophical terms, distributed compute networks like Lilypad can provide a host of benefits for participants on all sides of the markets. And this helps to combat philosophical issues like censorship, access, and anti-competitiveness, and also provides more efficient marketplaces, increased innovation, and better access, shared value systems, and distribution models. So this gives open source AI and new market entrants a viable platform to compete from. I love this quote from A16Z. They did a podcast on AI crypto, I think like fairly late last year. And this is exactly what they had to say about where AI and crypto kind of intersect. The vision is to make this really centralized product, AI, more democratized with crypto, because crypto is very democratic, whereas AIs can be quite centralized. So providing these decentralized compute networks, linking up to data provenance systems that we're seeing be built already, linking up to decentralized storage models, open source decentralized storage networks, open source models. If we can create these kind of plugins and infrastructure from a decentralized compute place, then we can create this horizontal, actually open AI vision. So I am going to leave it to Steve to dig into how does it actually work. Sorry for going on a little bit, but I just get really excited about what we're building here and I want to share it with everyone. Steve is going to walk you through the practicalities of how it, am I going to work? Actually, I'm going to walk through this part, aren't I? So my bad. I'm going to walk through some of this part and how it actually works, and then we'll move on to a demo from Steve. Your next slide. Okay, cool. So technical details, Lilypad's live. It's fully EVM compatible. It's built in Go and Solidity. The testnet is live. We're calling it, well, we're calling it the Lilypad Milky Way testnet. This is an upgrade from Aurora. Hurrah, we're up to version 3. This is the first time I've actually announced it, even though this won't go live for another week. You're hearing it here first. I don't know. This is the future. This is the future. Also, in future, we'll be deploying to multiple EVM chains. So what happens with Lilypad is we do off-chain compute and we do verifiability using smart contracts and some other game theory mechanisms, which I'm going to get into in a second. Those are built on Solidity contracts, which means we can deploy to multiple EVM chains and still have access to this compute network. So wherever you like to build your applications, you should be able to run Lilypad in the future. Lilypad everywhere, we're calling it. So Lilypad's made on top of this like modular architecture stack. It's designed for developer and user flexibility. So we're very big on making this easy for both developers and users to use. This is still in alpha, obviously, so give us some feedback, but we will keep working on making this true. So starting from the core code libraries, we add verification with smart contracts and services in the off-chain market matching network. And then we finally make it all approachable with easy-to-use SaaS layers for users and devs. In order to make sure jobs are performed as specified in the network, Lilypad uses a game theory approach to job verification or compute verification. So it uses optimistic reproducibility to incentivize good actors and discourage cheating and collusion in the network. Now, in practice, what happens is we have mediators on the network, which is not unlike L2 validators that check that jobs are performed as they've said they needed to be. So each node on the network has to put up a certain amount of stake in order to operate compute jobs or bid for compute jobs. And when they perform them correctly, they're paid. If that job is checked and it's found that they didn't do the job correctly, then they will be slashed that collateral. A client can also challenge the job, though they need to put up some level of stake to challenge as well. That's so that we don't get basically a DDoS attack on the network. So in future, there'll also be more privacy on the network. And as you may have understood from what I just said there, currently, because we're using an optimistic approach to checking that jobs are done correctly, it means that input in must equal input out. Doesn't matter which way you go to get there in the meantime, but that means it's deterministic. So all jobs on the network have to be deterministic currently as well. So we're working with an amazing researcher called Stanley Bishop to work out how we move to a place where we have non-determinism, and also to a place where we have some more privacy layers on the network as well. So both of those are being thoroughly researched at the moment. They'll be introduced in subsequent versions of Lilypad as we figure it out. We're also playing around with introducing just a direct marketplace to hire out a GPU without needing to know if the job is run correctly as well. Lots of things happening here, lots of things happening. So what exactly is a job, though, and these deterministic modules? So a module is basically a GitHub repo that defines a compute job to run on Lilypad. I'm probably saying that a little bit the wrong way around. Basically, a compute job is a Docker container or an arbitrary WASM job. It then has this GitHub repo that is the Lilypad spec, and that's how it matches to the GPUs on the network. So that's how the network knows what to run and how to run it on Lilypad. So there's currently several modules available to use, and we'll be incentivizing building more of those in future. So like Stable Diffusion, there's LLM, LoRa is coming, and there'll be, I think there's a sneaky one that Dev Steve is building. I won't ruin his thunder here though. So what's really great about this module system though is that it provides flexibility to users to define their own parameters for running compute jobs and what that job should look like. So it also has the advantage of being able to enable a marketplace. So if you're a module creator, if you've created a really cool job and you want to share it with other people, you could put it on our module marketplace and attach a small fee to that job. And then anyone else that uses that job would pay a small fee to you to use that job in perpetuity. Now, obviously, that's a marketplace. So if you're just wrapping an open source model, probably you're not going to attract too many fees because someone else will make it for free. But in general, if you put the work in, you should at some point be able to make money from some of your really cool compute jobs. And there's a lot happening on that side of things as well to build out the module marketplace with some reputation systems on top of it. There's also multiple ways, like I said earlier, we want this to be easy to use. So there's multiple ways to access the Lilypad network. There's the Lilypad CLI, which Steve is going to demo. There you can currently access through smart contracts, and we're going to make that flow even easier in future. And it will be on any supported chains in future as well. So we're targeting a few at the moment, but currently we're on our own DevNet, Ether DevNet, that just enables us to control faucet funds. So no one's sitting at a hackathon going, I can't access funds. We've got you covered there. So there's also the Lilypad AI Studio, which will be building out, or LilySAS that we colloquially call it, which will be building out as we go this year as well into having API keys as well as SDKs for developers. So currently this is under maintenance and we are working on building this out more thoroughly too. Stay tuned. Okay, enough of me rambling. Let's get hands on, Steve. You're up. Batter up.
Wait, do I do it now? No, I'm joking.
Yeah,
All right,
yeah,
let me switch screens. Oh wait, did you switch it back? Let me switch screens. All right, because I gotta do code things, the fun code, and it's totally gonna work the first time because this is not a live demo.
Absolutely.
Hello everyone. How amazing was that? I know you're all looking up to see the Peter Wang video to find out more about that amazing talk he did. But wait, there's still more. I'm going to show you how to get started with, not only get started with Lilypad CLI and how to install it, but also how to build your own Dockerized containerized jobs rather, to run on the network. So it's really easy. But let me switch screens first. So let's begin with who likes presents. Oh, we all like presents. Now you can make your own because here's a whole bunch of present gift box images that you can create using Lilypad. This is actually funny you should mention that, Ali, that we have a whole bunch of new modules coming because this is one. The SDXL pipeline module, and that's the prompt that I've used to create not only this one, but this one, well, I got a bit creative with these other ones, so you can adjust the prompt a little bit and add extra steps in to make it a bit more refined, which I didn't do on that one, but I started to do on that one. And you can kind of see it looks a little bit better. Plus the colors are so much nicer. I may have added a couple of rainbows in there into the prompt just to make sure, well, I mean, anything's better with rainbows, right? And more so with this. Anyway, here's how you do it. So you're going to need to start with setting up a testnet on your MetaMask, which is really, really easy, really, really simple. And if you wanted to follow along in your own time as well, you can also visit docs.lilypad.tech to be able to walk the steps through this as well and to grab all those details, because copying them from a screen or from a video from a past recording is sometimes not easy. So I'm also rambling a little bit just so you have time to input all that as well. Hopefully you've got it. And if not, again, like I said, it's in the docs. Once you've got that set up and you've got your MetaMask account address wallet address that you want to use with your test account, you can head over to the faucet and you too can have your own Lilypad tokens and imaginary ETH. What's not really imaginary? It works in our blockchain, but it does get you to make be able to make present images like we saw earlier, and a whole bunch more that we're going to look at. Maybe video. That is also a new module that hasn't yet been quite talked about, but I'm gonna show you how to do it. Of course, the other part to this is then installing the CLI itself, and there's a few different ways to do that. The first is using the binary release. So head over to the GitHub, and you can choose the binary release that matches your particular system architecture or particular development environment architecture. There is also another way to do that using some echo statements, which you can grab from the docs as well, if you wanted to do it that way, but this is also will work too. Once you've got it downloaded, you make it executable and then move it into the user local bin location in your development environment just your development environment. Is there anywhere else that we operate out of? Probably. The other way to do this, and probably the easiest way, is using the amazing Go. You may have heard of this language called Go. This is it here. Well, this is not it here. This is the logo from it. But once you install Go into your local development environment, you can literally just put one line. How easy is that? And it will get everything you need all set up and ready to go. Now, there's just one more thing you need to do before you get underway, and that is to install a web3_private_key with your MetaMask key that you funded from that earlier step. So I'm not going to step through how to get that in here, but you can just grab that private key from your MetaMask MetaMask account wallet, your little install thing, and probably in your browser or on your phone. Grab that key and then store it as a environmental variable inside your environment. And then you're good to go. You can type Lilypad and hopefully, all going well, you should have that particular prompt menu appear in your CLI, which means you're good to start generating all the things. Now, the place I usually like to start with to make sure everything's all up and running and all nice and happy is running the Cosay Cow demo, which for those that don't know, essentially does that. Oh, see what I did there? It doesn't. Now I need to point out here because it doesn't come with a Rick Astley, Rickroll. That was just an added extra. That was a gotcha. Once you run the job, you'll see a screen like on the left there where it'll run through the different steps in getting that particular job run, and then it will be outputted into your local environment like so. So then all you have to do in this instance anyway, now different modules, and we're going to look at through a few different ones in a moment, different modules will have different output types depending what the module does. So in this case, the std out is where your output, your calsay, I always say cosway, I don't know why, calsay will appear, your calsay ASCII will appear, and then you can just grab it with a cat, or you can also open it in your text editor too if you want. It does look better in doing it through cat because it kind of outputs better, and depending what shell you're using, it may even appear in some color, but yeah, that just depends what you're using. I'm just doing it default here to give you an idea on how it works. So one of the other ones we have, and now this is one of our newer modules, one of our new and exciting ones, the SDXL pipeline, which very similar to the last one, you just do Lilypad run, you put in your job name, so SDXL-pipeline, and then the tag version, so version 1 base Lilypad 3, and then the I is the input. So with any of our modules, the -I input means that's what you're adding to the particular job to be run. So in this case, we're doing an astronaut riding a unicorn in cyberspace, which looks a little something like that, which is kind of fun, but we can make it a little bit better. Here's one I ran earlier, another one I ran earlier with some refinement steps added, which again is another input prompt. So steps equals 200. Now these input prompts do depend on the actual module that you're running and the different flags and inputs that it can accept as part of its runtime. So always good to look through the different flags and prompts that the module can actually support. And in this case, well, it made it a little bit better, but sometimes you need to keep refining these things. Maybe it's a prompt thing to be able to get it, but it does look a lot more magical, I must say. The rainbows in this one are looking quite formidable. And speaking of, we can level that up even again with another. Oh, there was supposed to be some animations there, and it didn't quite work. Oh, there we go. Pretend we didn't see that. Let that one out. Now this does get a little bit more complex because we're also using an image seed. Sorry, this is the stable diffusion video generator, which is really new, and obviously needs quite a lot of GPU to be able to run it, which is good because we got Lilypad at hand, and also that amazing wallet with a whole bunch of almost unlimited credits in the testnet stage. Anyway, like before, we're just using the Lilypad run and then the container prompts. We've also added a image seed, which you can obviously play around with and get different results. We've got our prompt there, like before, like with the image creator. We've also got the steps to help refine it, and we've got the video steps, which defines how many frames inside the video are available. And obviously, the more of these you add in, the more complex it gets, the longer the runtime, the more GPU, etc. But the good thing is you can play around with it. And here's the spoiler from earlier. That's kind of what it looks like, which is not too bad. And you know what? It ran relatively quickly. Now we have a whole bunch of, like Ali said.
I'm interrupting just to say that is so cool.
I know, right? I know. Oh, actually, one thing I need to mention with that video, I'm gonna go back. Oh, see, there's so much going on. There we go. One thing I should mention.
Cool.
That's so cool. I know that actually comes out in 3 different video formats too. So that's the MP4 version. There was a animated PNG and also a WebV. What's a WebV? There's 3 different formats that come out anyway as part of the output when you run that.
I can't imagine
anyway.
where we're going to be in 6 months as well. It's just wild, the pace of development, just wild. Like, look at this. It's amazing. Anyway, carry on.
I'm totally creating a module, and this might be inspiration for somebody. I'm totally creating a module to turn up for me at meetings and like be me on video. But anyway, we'll work on that one.
I'm definitely cutting your salary. No, carry on.
Oh, we're gonna have to start paying the AI now. We do have this is a growing list. So this is the part of the current list. There's actually more coming because there's a plethora of explosion of ideas, including replacing me in video, but we'll get to that one later. Yeah, please check them out. They're on our GitHub repo and then also in our documentation as well. but you can actually make your own, which I'm going to talk about in a sec. I think Ali wanted to talk a bit about this one, the POC.
Oh yeah. For those of you that maybe didn't see this, we released this proof of concept last year, just before we started really building Lilypad up. And this proof of concept was called waterlily.ai, obviously named because of Lilypad, actually. Also, I liked the tie into Monet at the time. What's really interesting is this, like, a really good example to me of some of the things that AI and crypto can be used together for as well. So basically what this app did was use a pipeline that fine-tuned to an artist's style. So an artist was able to voluntarily come online, input their images, which were then deleted after the model was created, and like a fine-tuned stable diffusion model was created for their image, and then a user would come along and pay a small amount in crypto to get a stable diffusion prompt, so text to image, back, and we gave them 4 images based on whatever artist that they picked style. And that payment, that fee, went back to the artist minus the compute layer, but we were doing that for free, so all of it went back to the artist. And in the case of open source artists, so people that have been passed away for a long time, most of their works are in the public domain. In their case, we sent it to California creative space, actually. So I think this app really kind of shows some of the power of combining blockchain with its verifiability, its trust, and its kind of payment rails with something like AI for a better outcome. So in this case, we were trying to deal with the problems of attribution in AI, in creative AI. Yeah, little fun tutorial that I think really explains it well. And obviously it's not perfect, but I think it's a step in the right direction. Yes, I mean, I can also talk about smart contract usage. There'll be more of a tutorial coming out on this soon. I think we may have gone a little bit over already. There definitely will be more information coming out on how to use Lilypad from a smart contract as we go to deploy to other networks as well, other test networks. So that's in the pipeline to come out soon. Currently, you can use Lilypad from a smart contract, but it's not as easy as it should be. So you can use it. There is some information on how you would do it, but you basically need to set up a little bit of a server to enable using it from our smart contract at the moment. So it's not as simple as it should be. We're working on it. But if you want to have a go at that, there's definitely documentation around on how to do it.
Funny you should mention that. Here's the documentation. Also, I just want to say, if anyone does have a use case for this or a need to it, like, please reach out. We would love to chat and talk through that more and figure out how to make that scalably possible. Well, that was a good one.
Like a heap of use cases for the smart contract example, like things across gaming, for example. Like you could automatically create assets in a blockchain game based on certain outputs with a compute layer like Lilypad, and get them sent back to you. There's definitely DeFi use cases, as long as I think there's not a requirement for it to be sub-millisecond. DeFi use cases are possible. There's definitely decentralized science use cases that we're working on. And, you know, probably so many more that I'm not even thinking about right now, I think. But yeah, anyway, sorry, carry on, Steve.
See, that is what I love as a dev, is the endless possibility. I mean, this is a containerized compute network. How cool is that? You can literally run pretty much almost anything on there. So anyway.
Yeah, we dubbed it kind of Lambda Plus for a while, right? Serverless compute. So
we did. It's still
small jobs. So it's like Lambda Plus.
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 Also, if anyone is interested in running their own node as part of the network, you can do that as well. We're not going to cover in this session because there's not a whole lot of time. But again, please reach out, join the Discord, and we would love to chat through, or check out our docs, because we've got a really good write-up on how to do that, and you can run it on pretty much anything, which is what Ali was saying at the start.
And if you have like kind of, you're not just an individual node runner, you maybe have some higher powered GPUs or several GPUs or a data center or something like that, please get in touch with us. We're running kind of a calibration net with incentives at the moment, leading into our incentivized test net, which should launch later this month, where supply will be heavily incentivized to begin with. So yeah, keep an eye out for that too, or reach out.
Yes. So I'm going to run through quickly how to build your own containerized module rather to run on Lilypad, because, well, if it runs in a container, you can pretty much almost run it. Almost. There's some rules to that. Basically, where are we going? Oh yeah, there we go. There's a few rules around how to do that. Essentially, like I said, it's essentially a Docker, or if it can run in a Docker container, you can potentially run it, providing you run through a few different rules and it has the right structure and outputs to its containerized runtime. Essentially, you need alongside, well, first identifying a container to be able to run, which I did have a Hugging Face logo on here. Oh, it's dropped off of my animations. Maybe the AI did it. Maybe my alter AI did alter AI personality did it. Anyway, you can use the likes of Hugging Face, for example, or if they've got a containerized job that you normally run stuff in, or you have something that you want to containerize, this is definitely doable. The primary sort of main way to run this is using a Lilypad module JSON template, which needs to be publicly available for the network to be able to grab it and then be able to run it based on some different specs that you put inside. Now, essentially, this is a Go template where you can set Go templates to or use a Go template rather to set defaults and perform other template related options inside your spec file. So in the one here, this is actually another new module, not quite released yet. I got to tinker with it some more, that I've created called Lily Say, which we're going to look at in a sec. In fact, we're going to run it. But essentially, this is pulling in from a Docker Hub, and because of that, I'm also specifying if you're pulling in an image from the Docker Hub, which like what I am in this particular template, you need to also include the SHA-256 hash as well as part of the image identifier, just to make sure that so the network then makes sure it's pulling in the right image and it's getting everything it needs to be able to run correctly. The only other thing to mention there too is, I missed my go for animation. Where, as you can see in the file, we're also including the machine specs, so the GPU, the CPU, and the RAM. Now, this is a variation of the CalSay. Oh, got it right this time. The CalSay image, which is literally, I literally forked the original image and then repo, and then I'm pulling in a base image from the Docker Hub and then adding my own ASCII art on it. Oh, spoilers. So we didn't need any GPU for this particular job to run, just literally CPU and RAM, because it's a fairly light lift job. The other part of this is ensuring, and Ali touched on this in the first part, is ensuring determinism. I was trying to think up a really good tech joke here. I love tech jokes. So if you have one, please reach out and tell us, because we're looking for some determinism jobs. I'll tell you the outcome once we receive it. Oh, I think that might have been one. Anyway, we'll circle back to that one. So here's some guidelines to ensure that your jobs have a deterministic job output. Is make sure that the output of the module is reproducible. Say that 3 times fast. Make sure you strip out timestamps from the output. Now, while you are developing your job, containerized job, you also are probably going to run into some errors while you're developing. That's just development. There are some ways to be able to determine some of the outputs from that as well, which we also talk about inside our docs. But again, if you do get stuck, please reach out and join our Discord. We'd love to chat and help you through it. Also, just understand what you're building, because we've seen some amazing use cases come out so far. And one of the other things to mention is to avoid reading from sources of entropy, such as dev-random, for example, just so you make sure you get some nice solid output. On the containerizing, Dockerizing side of things, every day I'm containerizing lately. Yeah, that's me. That's totally me. Pretty easy is you build using a normal Docker engine. So in your development environment, you likely already have Docker, or you can install it. But essentially you build your container there first and then be able to, use it in your Dockerized environment, just using some prompts. And then from there, it's just a matter of tagging and then pushing to your Docker hub so that you can reference it inside your job run, which brings us to your job run. What I'm going to do now is I'll switch over. Essentially, running is no different. Running a Lilypad job for one of your containerized jobs is no different to the ones we were looking at earlier, except that you reference GitHub, your GitHub location where that template file is sitting, which will then reference the Docker Hub location, Docker Hub image with the appropriate prompts and whatnot. So what that looks like with our Calsay example, Calsay. Oh, I got it right this time. I thought I had. Anyway, from Lilysay, I actually did get it wrong. I'm going to switch windows because here's one I prepared earlier. Actually, we're going to run this one live. So while that's running, I might switch back because that's going to take a second to run. Actually, that's probably not going to take very long at all because it's already nearly finished. It's already finished. Oh, there we go. Oh, how was that? What a dream run. And as you can see here, I've got a few different lines of output. So I'm going to grab the std out path, and there we go there. See, got it through. Huh, how was that? Anyway, there we go. Now, one thing I do have to add to this is another input prompt switch so that I can switch between, there's actually two images loaded into, two ASCII art images loaded into the image. I almost tripped up. So yeah, I'm adding another switch into the next version iteration of this, which then it'll be done for now, because I mean, are these ever done? There's always that one little thing. So that you can switch between the different image types and add different prompts and stuff. Just a bit of fun to add to it. But it's important to note here that you can't pass an environmental variable, you can't pass variables through this way into an environmental variable like you will in the Docker world. You'll have to use an input prompt at this stage just to be able to pass those variables in, as you saw with the earlier examples to the more complex time. And that's probably it for my demo section. And hey, I'm just glad that demo worked first go.
That was epic. Really well done. That's awesome. Thank you, Steve. Amazing. I liked some of the jokes. That I think you almost did come up with a determinism joke there as well.
It was on the fly too.
It was on the fly. Hey, well done. Well done.
All right.
Let me just share my screen again, or I'll just use yours.
All right. Just say click.
Present. Shares. Actually, I've got it. Can tech. Woo. Sometimes. Yes. So like I was saying earlier, Lilypad is meant to be for everyone. So you don't need to be a developer to use Lilypad. You shouldn't need to even though it's super easy, get your command line up and enter a couple of lines of code and then start typing in what you want out of it. You don't need to be a developer to run AI. Part of our accessibility mission is definitely not to make it hard. So we actually have Lilypad AI Studio. Now this is running currently, but it's currently in maintenance a little bit. So it will be living on app.lilypad.tech, but we're upgrading it currently. So there's a few maintenance issues and you can't currently use it. But the idea is that LilySAS will be able to be used just with a Google sign-in. You won't need to deal with MetaMask, which is great for, just everyone else that wants to create perhaps integrations, plugins, or doesn't even know about MetaMask, but wants to be able to use these AI tools. So we want to bring these AI tools to everyone, basically. There's a video on using AI Studio up on our YouTube. So if you want to have a quick look at how it works, go ahead and have a look at that. The idea is this will have API keys, so you can put this in a front-end developer resource, and it will have SDKs, things like React Native. Potentially you can use this from mobile. Or you might be able to use this with a Unity SDK in hopefully towards the end of this year, we're hoping for, in your games and that sort of device. Or you can just use this in other DeSci applications as well. So we're trying to make this really accessible for everyone, whether you're a developer or not. Just want to share some resources while we wrap up here as well. So join the future with us. There's some ideas and resources. I know you're hacking this weekend, so there's a project showcase that is in our docs, actually, docs.lilypad.tech. Go and check out some of the other projects that people have made in the past. Now, bear in mind, some of these were on past versions just before you get started. But there's some great ideas in here on the type of things you can do with Lilypad that are still relevant as well. What's next for Lilypad? Well, we've got a lot to do. We're hoping in the next 6 months that we're going to make it to mainnet, which means we'll be launching to mainnet. There will be a live token. We should be on some dexes, and we should be building products everywhere, hopefully, by then. There should be some SDKs or API keys, and you'll be able to use this from a smart contract much more easily than you can today. And across multiple EVMs even. That's part of our Q2 initiative. Firstly, what's happening more short-term is we'll be launching an incentivized testnet, as I kind of mentioned a little bit earlier. Now we'll go through phases of that incentivized testnet. The first will be onboarding supply. So if you have a GPU or even a CPU in some instance, you'll be able to be incentivized to run on the network. The next part will be about incentivizing modules and building out that module marketplace I briefly spoke about. So there should be so many more AI and ML and other deterministic jobs, actually. Like Lilypad is not actually only for AI and ML. You can run any kind of deterministic compute job on Lilypad, and you can make any kind of deterministic module to run on Lilypad, and hopefully in future even non-deterministic. So that we'll be incentivizing building those as we go as well. So that's what's up next. So we'd love to see any kind of plugins, anything that would make it easy for other developers to use our tools, any kind of upgrades in the network that you can think of, built out for this hackathon as well. And I know how innovative you've been, because I've been around ETHGlobal for the last couple of years now. Big shout out to the team there, doing an amazing job each and every event. But I just know how innovative this Web3 crowd is. So I can't wait to see kind of what you come up with and build for our bounty prize there as well. Really excited that there's one in Australia and that we get to sponsor it. Like, that is just like, I don't know, it's like life goals right there. So anyway, we will leave it off there. I think we've definitely gone overtime now. Is that the end of this? I think it is. Good. Just checking. Awesome. Thank you for listening, everyone. Good luck with your build, and come and say hi. We'll be around.